Hello everyone and welcome back to today's video. Today we'll be doing a Leetcode median question, which is the binary tree level order traversal. So given the root of a binary tree, we have to return the level order traversal of its node values. So from left to right, level by level. So using example 1 in this case, what this means is that first you have to go to the right, from left to right to get all the node values. And after that, we have to go down to the next level, so we ascend down, and go left to right again to get all the values. So in this case here, the values that we have to return in order will be 3, because it's the first level. And after that, we see that there's no more values to the right of 3. So we ascend down to the next level, so level 2. And then we go from left to right again. So we have to return 9 and 20 in one array. And then after that, we see that there's no more values. And as such, we will ascend down to the next level, which is level 3. So although there's no subtrees for the node at 9, but we can see that there are values at level 3 for the subtrees of node 20, which is 15 and 7. So we have to include the children of 20, which is 15 and 7, and return them in another array, since it's another level. So for the trivial cases, which is example 2 and example 3, which I couldn't really show, it is that if the root is none, then we simply return an empty array. However, if there's only one root, then we just simply return the root in an array itself. So the first thing that comes to my mind is that we probably have to use a data structure such that the earliest item that we put in will also be the earliest item that we will take out, so that we can continue to inspect the children below it, which will be the nearest next level. In this case, recursion wouldn't really work because as usually when you recurse, you will ascend down all the way to the lowest base case first. But that's not really what we want, and it will probably make things a lot more difficult if we try to use the recursive method. So we should probably implement a queue system instead. So a queue system is kind of a data structure such that whatever things we put in the earliest, we can also get it out the earliest. So in this case, the data structure that I use will be arrays. So we can think of it as an example right here. So at first, when I have 3, I'll put 3 into the array. So basically, I will just append whatever that is at the highest level right here first. So 3 will go in. And after that, I see that there's nothing else. And after that, for the array, I will get the earliest element. So I'll pop out the one at index 0. So I'll pop it out. And then I'll take a look at the node right here. So as I can tell, for this node right here, its nearest children is going to be 9 and 20 respectively. So what this means is that I will be adding 9 and I'll be adding 20 into the array. And this is already popped. And then after that, I can see that once I've added all the children of 3, and that will mean that I can continue to take a look back at my array and pop out 9 and 20 respectively. So after this has been popped, it will be the new index at 0 because it's a queue system. So that means that the next element that I'll get will be 9. And after that, likewise, I'll take a look at the children of 9, which I don't see anything. So the result will be simply me popping 9, and I won't be adding anything else to the queue system, since 9 doesn't have any subtree. Then after that, I'll take a look at 20 by popping it out. And I can see that 20 has 2 children, which is 15 and 7 respectively. So what this means is that I will have to get 15, I'll add 15 and 7 to the queue. And once this is done, the next element that's closest to the queue will be the one that is popped out again, the earliest element. So since the earliest element after 20 will be 15, so 15 will get popped out. And there's no children, so I don't append anything to the queue. And finally, we'll pop out 7. And with 7 being popped, that means that we have finished looking at all the elements in our array. So now this begs the question whereby, how do we decide what level that it is? Because if it's level 1, then you have to add 3. And level 2 will just be 9 and 20. And level 3 will be 15 and 7, right? But then if you only have this kind of system right here, it's not possible for us to tell what level they are and how to determine whether the array for that level is done. So like example, we have the 3 in one array, 920 in another array, and 15 and 7 in another array. So what's the good idea is that we can probably introduce another variable which is called the level. So at first, the level will start off at 0, which is for the node 3 right here. So instead of appending just the node and then we popping it out, for the node itself, I will append it in an array of 2 items, such that the first value is the node and the second value is the level. It's the level. So what this means is that at first at level 0, I will be appending 3, 0, the node 3 and 0 to the array inside the queue itself. Okay, maybe I'll just draw it out again for a better illustration. So what I will do is that I'll be creating a queue, and inside the queue I'll be appending an array of 2 elements, which will be the node and the level itself. So for this case right here, I will append 3 to the array, the node 3 as well as its level into the array. So this will first be 3 and the level. So after that, I'll pop out the first element. So inside the array that I get back, I'll have the node 3, which is at index 0, and the level itself, which is at index 1. So what I can do is to take a look at the node right here, and when I pop it out and append its children, I will be appending the level plus 1 to it. So when I add the item into the queue itself, instead of just simply appending the node, I will append, for this case right here, it will be 9 and 1, as well as 20 and 1 respectively, because I'll be appending the level plus 1. So after that, this means that I have settled the node at 3 because it only has 2 children, 9 and 20, and it has been popped up. So now I'll take a look at the next element again, which is 9 and 1. So for 9, once I pop it out, I'll be getting back the array with the node at 9 and the level at 1. So now we can ask a question whereby we can take a look at the global variable and we can look at the current level. So if the level that I have here already exceeds the current level that I have, that will mean that I've already finished traversing through that level itself, which is level 0. So what this means now is that I have to take a look at level 1 instead. So once I meet a case whereby my level right here exceeds the current level that I have, then that will mean that I have to start a new array to append the values at the next level. To append the values at the next level right here. So what this means is that I first have to increment the level right here, increment by 1, because I'll be ascending to the next level. And that means that whatever children that I have for this level right here, I will also append the value of level plus 1 instead. So for example, the case whereby 9 doesn't have any subtree, that will simply be appending, in a sense, none left and right subtrees. But for the 20 right here, when I pop it out, then that will mean that for his children right here, instead of appending 15.1, I'll be appending 15.2 instead, as well as 7.2. So after that, I'll be done with the level right here for the 9 and 20. And then when I look at the next level itself, and that will mean that since this will be level of 1, while this has a level of 2, that will mean that I've already ascended to the next level. And as such, I can just simply append whatever temporary array that I've added, which will be the 9 and 20. And then after that, so what this means is that I can just simply append whatever values that I've accumulated so far, because that will be the values for the level itself, which will be 9 and 20. And then after that, we can take a look at the next level again. So this will be how the general algorithm will flow like, and maybe we can move on to the coding part so that perhaps it can make things more clear. So let's start with the coding part of the solution right now. So as per usual, let's start with some pseudocode first so that it's easier for us to see how a general algorithm will flow like. So first, we take a look at the kind of variables that we need. So first, I need a queue, which will be an array. I'll need a result to hold the results that I have, which will be an array, and a temporary result as well, so that I can hold the results, the values from each level. And there will be another array, as well as a variable to look at the current level itself, and that will be an integer. So first, we'll take a look at the base case right here first. So if our root is none, then we can simply return an empty array. However, if we do have a node at the start, then we add the root to the queue. Sorry, I mean we add the array with the root and the level to the queue. So after that, we have to always check while our root is not empty. While our queue is not empty, then we get the first index, the value of the first index, which will be the array of 2 elements. So we take a look at so we first have to check if the root, the value at the index 0 is empty first. Okay, maybe I just call this first. I'll just call this x, I guess. So there will be the array with 2 elements. First is the node, second is the level. So I'll check x node to see if it's none or not. Because by how our algorithm will flow, for let's say for example when we reach 9 here, we'll be appending none and none respectively as the root. But because it's at the back of the queue, we have to first do the check first. So if it's an empty node, then we can simply continue. But else, what we need to do is to first check the level. So if the level is the same, then that will mean that we're still on or we have values of the same level. So we'll just append the value to the temporary result. However, if the value is no longer the same, then that will mean that we have ascended down to the next level. So what we need to do is we have to increment the level first, the global variable right here. And then after that, we have to add all the results that we currently have in the temporary result to the result. And after that, we have to take a look at the children respectively. So after we have append the temporary result to the result, then we also have to make the temporary result empty again. So that we can continue to get the subsequent values. And what we need to do is that since the node that we popped out is already belonging to the next level, we have to add it to the temporary result as well, since we are not going to be touching it again. And once all this has been done, what we need to do is to add the children to the back of the queue with the level +1, since the children of these are those of a next level. And finally, we can return the result. So let's take a look and code it out right now. So first we have a queue, use an array, result, temporary result, as well as a level, which will start at 0 at first. So if the root is none, let's simply return an empty array. But if not, for queue, we add the root and the level to the queue. And for this part here, maybe I'll just write it down below. So our queue is not empty. Then I'll get the node array out. Pop. So what pop0 does is that it will simply get us the first element from the array, and then you will delete it. So it kind of like updates the first element respectively. So the node itself will be at index 0, while the node level will be at index 1. So So first you do a check. So if the node is none, then you simply continue because you don't have to do anything to it. But if not, then you take a look at the level itself. So if the level is the same as the one out here, that will mean that they are still on the same level. So what I need to do is to add the result, add a value to the temporary array. But if the node level is no longer the same, then like what I mentioned, I have to increment the level since it will be the one below. And after that, I have to add all the result that I have in temporary result to the main result. Since that will mean that I've already concluded the ones for the same level, then I make it empty again. And after that, I'll append it to the current node value that I have. Since that will mean that the current node that I'm looking at belongs to the next level. So once all this is done, the final step that I have to do is to add the children. So to the queue, I'll be appending the left child and level in the level itself, which is +1. Because like what I mentioned, I'll be looking at the next children. And the same goes for the other queue. I mean the other child. So once all that is done, then that will be how a general algorithm will flow. But we also have to handle a case whereby we are for the last level itself. Because for how our algorithm runs right now, when we meet the last level, we will never reach this step to add the temporary result to the result. Because the last level does not have a higher level below it with a non-empty loop. So what this means is that at the end of this while loop, we still have to do a final check to add the temporary result. So the temporary result is, if my temporary result is not null, then I have to add it to the result. Because like what I mentioned, if let's say I'm already at 15 and 7, then it's not possible for me to find another node below it with a higher level, and as such, I will never enter this else block. So with all that being said, I think the algorithm should be correct. So at the end of all this, we can just return the result. So for the time and space complexity, I believe that the time complexity will be order of n, where n is the size of the tree, because accessing the values in the array is a constant time. So all that needs to do is to check through all the elements in the tree itself, and thus is an order of n. And for the space complexity, I believe it will be an order of n as well, because we have to add all the items to the queue. So with that being said, I think that's about it. Okay, so actually I made a really slight error, which is that instead of it being root right here, it should instead be the node. Because we want to get the values, the children of the node that we're looking at. And the root is actually the root right here. So if it's the root, then we'll simply get time limit exceeded because we keep adding the children of the root respectively. So I think this should work. So yeah, that's the solution right here. I think it's relatively quick as well. And as per usual, if you have any questions, feel free to leave it in the comments down below and I'll do my best to address them. So thanks for watching and hopefully I'll see you soon.